It's not allowing me to write, that is the problem. I'm sorry, it's not allowing me to write. There is something wrong with my PC. Okay, so we'll go without much writing part probably. Yeah. So this is the best software where we can execute both 16-bit and 8-bit instructions. Okay, and this is what we are going to use in our entire lab session. Okay, and this other one, emu8086. This is also a simulator for the 8086. It can execute both 8-bit as well as 16-bit instructions, but it is command prompt based. It's a DOS command based system. It looks a little complicated to learn in the initial, but once you're familiar with the like DOS mode, like this DOS box mode, you can easily use this software. But still, this also I'm avoiding to make your life comfortable. So I'll show all the 3 websites because your electronic specialization. If you find time, please explore all these 3 options so that you will also have a better knowledge. So first one is you can go to emu8086 and 8086. So you can get the software from many places. You need not to go to only particular software. Like if you look at here, so there is a website here directly. You can use this website instead of searching here. So this is easy way to search. This official website for the simulator. You can go to download and you can download the required file and you can start working on it. Okay, this is little complicated initially, and this is GNU8085. You can see my screen, right, all of you? Please, someone respond. Yeah,
Yes,
fine.
sir. Yes, sir.
Yeah. So this is the another one, GNU SIM 8085. Here you can go to download and you can download the Windows version, 32-bit version here, and you can also work on it. So if you want to use this also, you can go to YouTube and you can find a few tutorials, 1 or 2. You will understand how to use and all. Once you're familiar with the software, and you can do the rest things similar, because the language will not change, only small changes will be there that you need to understand. Okay, and the last one is the emu8086. Okay, so this one we are going to use in our lab purpose. So there's a website, either you can go to emu8086. Most of the time this is down somehow, I don't know. It was working till a few days back, but it was not working nowadays. So this is one official way. If it is not working, there is a GitHub page by one of the member. You can go to his homepage in GitHub. Okay, there you can download this software. So to download the software, this is entire software files. Don't worry. Just go to code and download the zip file. Okay, once you downloaded and go to your download folders, you can see, right, all of you?
Yes, sir.
Yeah. So in downloads, you can see one zip file emu8086. Just extract it. Since I already extracted, I'm going to show you extracted file here. So you can see here this extracted file. So what you do is you just go to emu8086.exe, this file, this particular one, and just double click it and just run it. One of the way I run as administrator. So once you do that, it automatically install everything. It will not ask anything. It will be installed. You don't need to worry about it. Okay, to check whether it is installed or not, you go to your PC, go to C drive, and you will see one folder here. I'm sorry. Yeah. So if it is download, if it is installed, you're going to see a folder emu8086. Can all of you see here where my pointer is there?
Yes.
Yeah. So you have to go to this folder and you can see it is already installed. Okay, you don't need to worry. Okay. Then you can go back to your downloads. Then go to the where your unzipped folder here. Then you can click it once. Now it will open the software. It will not install now, it will open the software. So it is starting now. So this is a window, it will come first window. So don't update it. Even if you try for update, it will not go to, because this website is not working now. I don't know. Okay, just skip to the later part. So this is a welcome window which you see when you start the software. Can all you see, right?
Yes.
Yeah. In this, the registration key, everything probably I'll give it to Pradeep. Like we do have some keys, okay, which are which I got it from YouTube. Few people shared the keys. So you can also take the keys and you can register it. No problem. It is as long as you use it for academic purpose. There is nothing wrong. You can do that. Okay. So here you have four options: new, code examples, quick, start tour, and recent files. So recent file means if you already used it, you can use this button. Quick start tour means it will give you overview of this particular software. Code examples means they already have some example programs for you to understand how this emulator or simulator works. And new is our choice because we are going to start the simulation. So you press on new and don't select anything other than COM template. Don't select exe.bin.boot, all those things. Select because you can create boot file, boot template, exe file also from the software, but our interest is only .com template. Okay. Press on .com, you're going to see this window. Can you all see, right?
Fine.
Sorry?
Yes, sir.
Yeah. So here you can see origin 100H. All of you can see, right? Say, sir, no.
Yes, sir.
Yes, sir.
Yeah. So this origin H is the starting address of your instruction, and ret is a return instruction. You must have seen in C++. C++ will end somewhere, right? What do you write at C++ language?
Written zero.
Return, right? So similar way, you also write the same thing. In between, you can see here, add your code. So this is a place where you are going to write your assembly language code. Whether you want to do comparison or multiplication or addition, or maybe you want to interface something, you want to produce something, whatever, you are going to write the code here. Okay. So this will come back how to write code and all for the time being. So this is the first thing you are supposed to remember. So let me do it once again. Just double click it, it will open. Do it later. Click on new and choose the COM template. Press OK. Then here I'm going to show you what are the options you can do with this. Okay. First thing is you can go to help file, go to documentation and tutorial. This is the most important one you're supposed to explore. If you press, you're going to see all the related documentation, which is very much essential to run or use this simulation. So if I press, it will go to the Firefox window, but the files are stored in our computer only. Irrespective whether you have internet or not, doesn't matter. You can still access the help instructions. So there are certain sections in which you can read and understand certain things, but I'm going to tell you only few things here. So first one is the 8086 instruction set. Listen carefully. These are the instruction set which are supported by this software. So some instructions may not be available here, but most of the instruction set is covered. Did Dinkar sir said any instruction set?
Sir, most of the but still left instruction.
Sorry?
Sir, most of the done, but still there left instruction.
Oh, okay, okay. Yeah. So anyway, some of the things will be covered and some of the things you will explore on your own. Don't worry. So by the time you finish this lab session, I request everyone to at least use once all these instructions. Some of them I'm going to use it for when you explore the lab sessions, but some of them I may not use because you can use different ways for a given program. So make sure all these instructions you should able to use. Then only you will understand more and more. Okay. this instruction set is very much important for this particular simulator. Of course, some of them are very common for all the simulators. Some of them are very specific to the simulator, but most of the things, basic things will be same. That won't change by any means. Okay. So this is the most important thing you have to learn for this particular software. Then go to the interrupts. You have a different interrupts. So you also use all these interrupts. Okay, wherever it is required for your programming and all. Okay, then go to tutorials and you can find other tutorials which is required. So this is a thing you're supposed to read and understand at the earliest possible so that you can explore more and more your 8086 microprocessor programming. Okay, so this is your software thing and what are the things you're supposed to get it from the help file. Then you can also see the ASCII codes. This we already seen in your digital design course also. For each one, what is the ASCII code? Okay, for a given letter, what is the ASCII code? Okay, so this we already seen in. Then mathematics also we have a base calculator will be there. You can use decimal calculator. You can use hexa calculator. Okay, then you can also have converter, base converter. You can convert it to ASCII characters, octal, binary. If you give some number in hexa number, let's say if you give, let's say F. Okay, corresponding binary number is generated here, corresponding octal number is generated here, corresponding decimal number is generated here. Okay, so you have a base converter which is inbuilt in the software to check when you do some operations. You can check out. Then you have emulator. Then this is a place where you are going to run your or show your execution process. Like when you run your program, when you run your code, that is a place where you are going to see all your executions. Okay, so before that, let me show you one slide and I'll get back to you for again these two software once again. So this is the internal structure. I think Sir must have told you, right, all of you?
Yeah, sir.
Yeah, so in this instruction, listen carefully. We in our simulation we can see all these registers. Listen carefully. We are going to see what are the values stored in AX register, BX register, 16-bit registers, and CX, DX, and other stack pointer, all those things. We are going to see, like visually, we are going to see how data is changing in the registers when you do certain arithmetic operation or certain logical operations. Okay, and this is execution unit and this is a bus interface unit. Anyway, this will be covered in theory. So what I'm trying to tell you is you are going to witness the changes happening in the registers when you execute a particular instruction, and corresponding results also you can see. That's what I'm trying to tell you here. So now I'm going to show you how this will be visualized in emulator. Okay, so if you go here and click on emulator, show emulator, then you're going to see the actual emulator. This is where, so can you all see registers here, left side? Can you see or not?
Yes, sir.
Yeah, so in these registers, you are going to see your results. Most of the time, you see results in your accumulator register when you do addition or maybe multiplication or any logical operation. And correspondingly, you can also see other stack pointer register, all those things. Okay, and this is a place your code will come. Like when you write the assembly language code, the corresponding code will be generated here. Okay, and so that's what your emulator will show you. This is a very basic stuff, like how the registers are changing values. And when you want to interface external devices, okay, suppose you want to show your result on a 7-segment display, or you want to interface and control the stepper motor, or else you want to control maybe a traffic signal. So we do have some virtual devices here. So first one is a LED display. So you can get LED display here. So these LEDs, the 7-segment display, ideally it is 7-segment display more or less. Okay, so we can program, we can see our results in 7-segment display. Else we can also have stepper motor. So we can run the stepper motor based on our requirement, which speed is supposed to rotate clockwise, anti-clockwise. And we do have traffic lights. Like you can write a program for the traffic lights, like under which condition one particular line will be get the green light. All those things can be written in this particular one. So these are having very limited virtual device. We do not have many virtual devices to interface. Okay. So this is the emulator, and you can also see the memory. So this is your memory. Okay. You can define your memory location which you want to see. You can access that particular memory location, and you can edit the memory if you want to store your result, or if you want to read your data from the memory location. You can also store here. You can just click it and you can just edit it directly. It will directly edit it here. Now tell me, each memory location is, what is the width of the memory location? Yeah, 1 byte. 1 byte is the memory. 1 byte memory. Each memory location is 1 byte. Okay. So these are the basic things which are available with this software. Okay. And here the single step run, this will come back when you do the simulation part. Okay. Now what I'm going to show is the real what we are supposed to do in laboratory session. So let me go back here. So this is the original board which you are supposed to do it offline. Suppose if it have been yeah, somebody asked, please Jeet, who is Jeet? Is mic is on? Yeah. So you can see here, this is the original board in which you are supposed to do all your microprocessor instructions. Okay. If you look at here, this is actual microprocessor. This red color one which I'm drawing line. This is your microprocessor 8086. This is a kit, 8086 microprocessor kit which we have in our laboratory. We are having almost 10 to 15 number. So that means each one can do it on their own individual board. Okay. And if you look at it, there are many external things here. This is only processor. So if you look at here, this is one processor 8086. And you have a co-processor. This is co-processor 8087. Okay. Then followed by ROM and RAM. So this is, if you look at the number 62256, and this is also 27C52. So you have two memories here. This is the one memory. This is another memory, like you are having a RAM and ROM and RAM. Then you have 8255 PPI. So you can see this is 8251. So this is URAT. Okay. There are other ICs. These are all another set of basic ICs. I'll share this PPT. You can go through the IC numbers and check out what are those ICs. Okay. And you have LCD display. So if you don't have any computer, you can interface a keyboard. That means you can connect keyboard. Okay. So you can connect keyboard through a VGA cable. Okay. And you can type instruction in the computer in the keyboard that will be displayed in this display. And similarly, you can also see the results in this display directly. This is one way of doing it. Else you can connect through a USB port. So you must have one USB port somewhere here or here. I think this one, I think somewhere here, I guess. Okay, you can connect to the computer, and you have a software associated with this board. Like this, each microprocessor board comes with a software from their manufacturing company. This is from Bangalore, Electro System Associates from Bangalore. So they provided a software. That software will communicate with this board directly. That means you are going to type your instructions in the computer. The computer will send the instruction to this microprocessor through interfacing, and it will execute, and you can see the results in the computer. That is one way. Otherwise, you can interface the keyboard and you can write the instructions, see in the LCD display, and you can also do it. This is second way. And you have extra connectors here. This is 20-pin connector. These connectors are used to communicate with the external world. That means suppose you want to display your result on a 7-segment display, or you want to control a stepper motor. In all those cases, this 20-pin ribbon, there will be a ribbon. You must have seen 20-pin ribbon, right? Did you see or not? If you see old printers, you will see ribbons. Did you see ribbon cables or not, at least? No, yes. Tell me at least. You have not seen ribbon cables till now. this is a kind of a strip. You have all the wires which are not connected internally, but they combine together, form a small jacket here, like kind of a opening. This will connect to a given.
Display wires.
Yeah, display. Yeah, that's it. So that's nothing but a kind of a display wire only, but here it is interfacing wire. Okay. So this will be for the external connection to communicate with the external devices. So whatever you do it, that will process in this 8086, and this 8086 will further communicate with all the external devices, either display or RAM or VGA cable, whatever it is. And you do have a crystal oscillator to produce the crystal like your clock. Okay, so these are the different parts which are available in our board. I'm sure you will be coming back to campus maybe after a month or after 1.5 months. So you will definitely exploring this board, how to use this board and how to use 8086 physically instead of using a simulation. You can also use directly. Okay. So this is what you are going to use in our laboratory. And let me go back and let me show you some more. So this is a external device, 7-segment display. So like what you see in the simulator, you can display your result which is coming from a microprocessor that will be communicated to coming through a cable. So this was this again 20-pin cable input. So whatever the cable coming from the microprocessor kit, that will be connected here. So this will be your 8086 that will be connected here. And whatever the results come from 8086, that will be displayed in this particular display board. So you have a communication, like this kind of a interfacing, okay, to communicate with the external world. Similarly, you have a stepper motor. So again, you can see there is a 20-pin ribbon input. So microcontroller will give the input to here, like the resultant values to here. Based on these values, these four drives the stepper motor, either clockwise or anti-clockwise. This again interfacing a external device by using 8086. This is a traffic light controller. Whatever you have seen in the simulation, the same thing. These are the traffic lights. You are going to control these lights using your communication, your assembly language code. That code again pass through this 20-pin ribbon and it will communicate with the external devices. So these are the interfacing devices which are available in laboratory. These are available in our lab. So when you come back to offline, you can access all these modules to communicate with the 8086 processor. Okay. Is it clear, everyone?
Yes, sir.
Yeah. Now we'll start our first program for today. So in the first lab session, we are going to see only very basic arithmetic operations. We are not going to do any complex operations. So as you already know, your 8086 can handle both 8-bit as well as 16-bit instructions. So if you want to use 16-bit data, 16-bit input, you have to use the registers as AX and BX. If you want to use 8-bit, either you can use AL or BL or AH or BH. This was told, I think, in the class, right?
Right.
It's discussed, right?
Yeah.
Yeah. So now in what we are going to do is, we are going to store some information in the AX register, store some information in the BX register. Store in the sense I'm going to push some data into these register by direct addressing. Okay. Then I'm going to do addition operation of these two, subtraction operation of these two, multiplication operation of these two, and division of operation of these two. Okay, that's what I'm going to do it. Okay. So let me show the program in the simplest way. Listen carefully. This is a program which I'm going to execute in 8086 emulator. So yeah, as usual, this will be default. It will come. You don't have to put these two things, origin and return. You can see my PPT is clear, right? Is it clear, right? Is the PPT is clear?
Yes, sir.
Yes, sir.
Yeah. Yeah. So what I did is initially, this is not compulsory. These first 4 instructions are not compulsory. Since to make it more clear, I cleared all the registers with the 0 values. Is it 16-bit data or 8-bit data?
16-bit.
16-bit data. So I cleared my AX register with all zeros, BX register with all zeros. Okay. If at all, if something was there with the previous execution or previous file execution, that will be cleared. so that there won't be any confusion. Okay. Once I cleared all my registers, what I did is I use the instruction move AX comma some number. Okay. You can keep any number. So in this case, I kept 21H. Please listen. If I write 21H means it take it as a hexadecimal number. If I write 21H means it is hexadecimal number 21. If I write only 21, it is a decimal number. Listen carefully. And this processor will convert this back to hexadecimal number. So it's up to you. Since machine already knows hexadecimal number, I am directly writing 21H in hexadecimal number. So the moment I execute this instruction, this 21 hexadecimal number will be stored in the AX register. That means your AX register will be something like this. Your AH will be there, AL will be there. Now tell me what are the values I am supposed to get here after this instruction. AH will have
1.
2,
0, 0,
0.
0, 0, then
2, 1.
2, 1. So this is first instruction where I directly moved some data to A register or AX register. Suppose if you want to use only this particular one, you can still replace AX by AL. So it will execute only these two, remaining will be 0. It's up to you whether you want to do it 8-bit or 16-bit. Similarly, next instruction I moved BX value with a 1 hexadecimal number. That means my BH and BL will be something like this 0, 0 and 1, 1. Okay. Now these four are my syntax in 8086. These are syntax in 8086 or instruction set. I think this must have discussed, sir, I guess, right?
Yes.
Yes, sir.
Yeah. So listen carefully. When you add, it will add accumulator. It will add the B value to accumulator, and results will be updated in the accumulator. So that means when you add 21 and 11, so it will be 2 plus 1. 1 plus 1 will be 2. 2 plus 1 will be 32 will be your answer. This 32 will be replaces your 21. Agree?
Yes, sir.
Yeah. Now AX value is now not 21. Now it is 0, 0, 32. After executing the additional instruction, your value will be 0, 0, 32. Now next will be subtract. So now you are going to subtract your 32. That is a new value of your AX value, minus 11. It will be 21. Now your A value further changes back to 0, 0, 21. Agree?
Yes, sir.
Yeah. Now when you do multiplication, you don't have to give AX. Default multiplication will be always with accumulator. So when you write multiply BX means it's going to multiply AX with the BX. That means the 21, this is a new value. This is a new value which is coming after the subtraction instruction. That is 21 will be multiplied with 11. This 231 will come. Now your A value will be replaced by 0231. Fine.
Yes, sir.
Yeah. Now the last one will be division BX. That means whatever the value of AX, that will be divided by BX values. Now AX value is 231. Your 231 will be divided by 11. So you're going to get 21 as a division. This is your answer. So this will be finally appeared in the accumulator register. So this is what supposed to happen in the simulator. Now we'll take this example and try to simulate and show you how this is going to work for us. Okay, is it clear, everyone? Any doubt you can ask. This is, since it's a very basic level, you can ask if any doubt is required to be clarified.
Doubts.
Yeah, then fine. We'll proceed to the simulator and we'll start one program. So since I already tested this particular program, so I just going to open the same thing. So whatever you written, same thing. Don't worry. There's nothing complicated here. The same thing. You start with origin, cleared all the registers, then mode AX with 21, BX with 11, then addition operation, then subtraction operation, then multiplication, then division, then return. Okay. So once you return, you have to save. Okay. Suppose let's say if I want to create a fresh one, let me make it more clear for you. So let me take a new one. Let's come. Then paste your code or write your code. Then you have to save. So save here. So make sure save dot with .asm. Don't save with any other extension. Okay. Since we are not providing any extension here, but you have to save in .asm because we are writing assembly language code. So lab1.asm, I'm keeping it as. When you go to microcontroller, you have other extension .c, other extensions are available. But this is only having only .asm. So lab1.asm. Now you wrote the code for the particular operation. Now your code, now you have saved. Now you are going to compile it. Okay. So it will tell you if any error is there. If there is no error, you can just close it. If there is error, it will show you. Then go to emulate. Now listen carefully. This is the most important window. You have to be very careful. I think you can see my window clearly, right? All of you.
Yes.
Yeah. Listen carefully. Now you can execute by pressing the run button. If you press the run button, all the steps will be done in automatically. You end up with the last instruction result. Suppose if I press run button, your addition, multiplication, subtraction, everything will be done till the written part. At written part, it will stop the execution. Now, if you do that, what will be the accumulator value, AX value? Tell me.
11.
11, 21.
21.
21. So we'll see that first. Okay. So let me just run directly to make you just to understand it. Done. Can you see your AX value now? All of you. Say sir. Yeah.
Yes.
Now the problem is we could not see anything what is going on. Okay. To avoid this problem, what we can do is we can just reload it. Okay. Now we are going to do step by step. So that means first step, A will be cleared. Can you see if this color is moving? This yellow color and this blue colors are parallelly moving. Can you see all of you?
Yes, sir.
So if you look at here, move cx comma 00h will take 3 memory locations. So this is a machine code which is generated. So if you look at here, B918500000, this is nothing but this is assembly language code and this is a machine generated code and this is our instruction. Okay. Now, if I go to the next instruction, it will give you dx value 0. So if you go back here, step back here. Now, what is the cx value? Tell me here now.
001B.
1b. So if you look at the instruction, move cx comma 000h, that means now this cx value going to be cleared. You can see in the next instruction. Is it cleared?
Yes, sir.
Yeah. Now dx value going to be cleared if anything is there. Now dx also cleared. Now in the next instruction, your ax value going to change with 0021. So you can see now. Now your x value is changed to 0021. In the next instruction, what happens?
BX value change.
Yeah, bx value will change to 0011. So 0011. Now you store two numbers. Now you're going to do the addition operation. Now if you do the addition operation of ax and bx, as you already seen, your answer is supposed to be 32. 32 will appear in which register?
AX register.
AX register. Now we'll see whether it will change or not. You can see now. Is it changed? Your AX value changed to 32, right?
Yes, sir.
Yeah. Now if I do the subtraction operation, it will change to again 21 because 32 minus 11 is 21. Now we can see. Now again change to 21. If I do the multiplication, it will change to 0231. So we'll see. Now 0231. If I do the division operation, it will change to 21 again. Right? Is it clear, everyone?
Yes, sir.
Yeah. So this how you can execute step by step, or you can execute all in one go. It's up to you. Okay. Now Listen carefully. I'm going to run it once again, full run. Now done. Listen carefully. Now your A value is something, B value is something. Now if I do step by step, my A, B value is also cleared initially. You can see now. I'm sorry, it started. I have to reload it once again. Yeah. So again, you have to start from 0. So this is how you can execute each instruction. You can check how your accumulator values are changing, your BX value is changing, how result is changing and all. Okay. Is it clear, everyone?
Yes, sir.
Yeah. Now we'll go to the next one. That will be the last part for today's lab session, and I'll stop for today. Okay. So this is for 16-bit. So what you do is you try to do 8-bit separate, 16-bit separate program. So that means you use only either AL or BL or AH or BH and try to execute the same instruction, check the results, how the results are coming. Okay. And coming to the next one, now we are going to see basic logic operation between the data. That means you are going to see AND operation between the 16-bit data, OR operation between the 16-bit or 8-bit data, or NOT operation, whichever the one you want, or negotiation, or XOR or NOT, whatever you want it. So there are different logical operations. Okay. Since you already know AND operation means this simple AND operation, multiplication or mean addition of bits. So here NOT means, what do you call NOT operation in general? There is a name for that. I told you in the last semester. When you complement all bits, what do you call?
Active low.
Active low or anything else? One's complement. Did you remember?
Okay. Yes, sir.
Yeah. So of course, active low also fine, but usually NOT operation nothing but producing a ones complement of a given number. So that means when you write NOT operation in 8086, it's going to produce a ones complement. There is another syntax called NEG, negation. This will produce the twos complement. So make sure, remember this. This will be an important interview question. What is the difference between NOT operation and negation operation in 8086? So NOT operation will produce ones complement, negation operation will produce twos complement. That means it will produce a ones complement first, then add 1 to that, and finally produce the answer for us. Okay. Now we are going to see how we are going to write the program for this. It is same as previous thing. I did not change anything. I changed only few things here. If you look at here, I changed only these things. Rest are all same. Agree?
Yes, sir.
Yeah. So instead of say in multiplication you cannot keep AX, default it will take. So in this case, you have to write all the things AX comma BX, AX comma BX, end operation, OR operation, then negation operation, NOT operation. Okay. Now, so this anyway, this first 4 instruction will clear all your register values. And this instruction will make your AX value with 2 1. This is nothing but 2 1. Then BX will be 3 1. Is it fine, everyone? These two are fine in binary form.
Yes.
Agree? Now, once these two instructions are over, now next instruction will be end operation of AXeth with BX. So end operation nothing but multiplication operation between the each bit of AX with each bit of BX. So if you look at here, end operation means 1 into 1 will be 1, 0 into 0 will be 0, 0 will be 0, 0 here. And 0 into 1 will be 0 and 1 into 1 will be 1, rest will be zeros. Now, when you do end operation of these two, AX value and BX value, what you are getting? What value you are getting? 21. Is it clear, everyone?
Yes, sir.
Yeah. So now, after executing this particular instruction, your AX value is changed to 0021. Since I am not using any higher order bits, so I did not consider these values. Okay, but when moment you write AX value, you are supposed to consider other bits also, other 16 bits also, but since those are zeros, there is no value for them. Okay. So once you get the end operation, that is giving a 21 value. Next will be OR operation of AX and BX. That means now you are going to do OR operation of your AX and BX. That is, AX is nothing but now current value is 21 and BX value is 31. Now you are going to get the OR operation of 21 with 31. So this is 21 in binary form, 31 binary form. If you do the OR operation, is nothing but addition. So 1 plus 1 will be 1. Addition, not addition, actually it's a logical one. So 1 plus 1 will be 1. And all zeros will be all zeros here. And 0 plus 1 will be 1 and 1 plus 1 will be 1. Okay, now you're getting a 31. Is it fine? This is a new value of AX now. Agree?
Yes, sir.
Yeah. Now after this instruction, your A value is 0031. Now next operation is negation operation. Negation operation. Negation operation means it's going to produce the complement followed by addition of 1. That's nothing but a 2's complement. And whatever you're going to get it here, that will be again produce another complement here. Okay. For the time being, just exchange this instruction to make it more clear. So let's start first NOT operation, then negation operation later to make our life more comfortable to understand. So now after the OR execution, your value of AX is 0031. Now if I execute the NOT instruction, NOT comma AX means whatever the value in AX that going to produce a 1's complement. Now your NOT operation of 31, I'm sorry, this is 31. Okay. So that means 0 0 and 0 0, 31 will be 0 0 1 1 0 0 1. That's it, right? Now you have to
Yes, sir.
complement. That means you have to make all ones here, all ones here. This will be 1 1 0 0. This will be 1 1 0. Now tell me what is the value? F. Then what is the 1 1 0 0?
8.
8. 1 1 0 0 is 8.
Sorry. 9.
C, right?
C, sir.
C. Then E, right?
Yes, sir.
Yeah. So that means after OR operation, if you do the NOT operation, you are going to get a result of FFCE. Okay. Now if you add 1 to this, then you're going to get the negation operation. Suppose if you do the negation operation after the NOT operation, okay. Now this FF value, FFCE will get complemented. That means it becomes 0 0 0. Then this will be 0 0 0. Then this will be 0 0 1 1. This will be 0 0 1. Then add 1. So you're going to get it as 0 0 1 0. Then 0 0 1 1. Then 0 0 0. Then 0 0 0. That means you're going to get it as FF. So 0 0 1 1 will be C. Then 0 0 1 0 will be 2. So that means you are going to get it FFC2 as negation operation value, and this is your NOT operation value. Please note it down, some of you, because we are going to check it in the simulation. So FFCE is your NOT operation result and FFC2 is your negation operation result. Is it noted down? Anyone?
Yes, sir.
Yeah. Now we'll run the same program in the simulator and we'll try to see what kind of result we are going to see, how it is going to perform. So let me open the simulator, just close this one or open directly. So let me take which already written. So as you can see here, this is same thing as what you have written. Let's take another extra origin file, remove this one. Here all the registers, then you move 21 to AX and 31 to BX. Then you did the AND operation that is given 21 and OR operation that is given 31, right? Yeah, 31, yes. So this has given 31. Listen carefully. If you want to write any comment line after your program, just put the semicolon. You can write whatever you want it here. So suppose if you want to write something over here, You can put somewhere semicolon here. You can write this program is written by, or this program is logic operation. Okay, and your name. Okay, whatever your name or your PIN number, whatever it is, all those things can be written. Whatever the text which is after the semicolon, that will not be executed. So you can write whatever you want it in the description. So if I want to write description here for the first instruction, I can write semicolon clearing. Okay, so I can write clearing AX register. Just for the user understanding, nothing else. Okay, so now we'll try to see how results are going to come out. So we'll emulate it. So you can see now we'll start with initial things step by step. First step, AX going to be 0 0, then BX going to be 0 0, then CX, then DX. Now I'm going to move 21 to AX register. So you can see now 21 is moved to AX register. In the next step, 31 will be moved to BX register. Now you're going to perform the AND operation. That means AX and BX. That answer is 21. Now you're going to see the answer in AX register. You're getting AX value 21. All of you, can you see?
Yes, sir.
Yeah. Now in the next instruction, we are going to see the OR operation of 21 and 31. That is going to give 31 answer. Let's see. Now you can see your OR operation is given 31 as result. Now, as I said, I want to perform NOT operation first. That means you're having AX value is 31. If I perform the NOT operation, I'm going to get it FFCY. Why these two Fs are coming? It's a 16-bit number since we consider AX register. So AX has two zeros here. These two zeros becomes two Fs when you go to the NOT operation. Now you're going to do the NOT operation of AX, that is 0031 becomes FFCE. Sorry, this is FFCE. I'm sorry. I cannot edit now. We can edit later only. Is it fine? FFCE only, you got it right?
Yes, sir.
Yeah. So now if I going to do the negation operation, so negation operation means you have to do the 2's complement. Now we are going to get it 0032. Let's see. Now you can see negation operation is giving 0032. So this is how you can perform basic arithmetic operation and logical operations. Is it clear, everyone? Is it clear, everyone?
Yes, sir.
If you want any doubt, you can ask me now, because later part I may not discuss the basic stuff. So if you have any kind of doubt, you can ask, no issue. If there are no questions, so your job is, first thing is you have to install the software in your PC. Second thing is you have to submit the lab report. Okay, this consider the lab report 1, basic arithmetic and logic operations both. So please make it serious, keep all the files safe. Basic arithmetic and basic logic operation with direct addressing. This is direct addressing. Listen carefully. Whatever we have discussed today is direct addressing. Okay, and make sure please write the program clearly. If you needed, you can keep the semicolon, describe the each instruction what it is doing. And when you do the execution process, at each instruction, whenever you do the OR operation or AND operation, you try to take a screenshot of the register values, how the register values are changed after that particular instruction. Okay, so it's not just like that. You have to keep a screenshot for each action. When you do the OR operation, what is the result of the register? Then AND operation, what is the value of the register value? Then NOT operation, what is the value of registers? Okay, you have to keep everything in the lab report properly, the neat screenshot. If possible, please write your name on each program at the top. Just now I have shown you, after semicolon you can write whatever you want to describe. Okay, so this is all for your today's lab session. In the next lab session, I'm going to show you indirect addressing. I think sir must have told in the class, I guess. Told, right?
Yes, sir.
Yeah. So what we are going to, we are going to perform the same operations. Okay. So we are going to store some data in somewhere. Okay. This data we are going to call back to AX registers and BX registers. And whatever the results you are going to get it, that result will be again stored to some other memory location. Okay, that means your end operation result will store somewhere, your R operation result will somewhere, and your XR operation will store somewhere. Okay, so and your AX and BX value will be stored somewhere. So you can cross check all the information. That means your AX value will not change repeatedly because you are taking AX value from a memory location. Okay, so and results is storing at different places. Every time you can call back AX value again to the same value. So you can do the same operation. Only thing is you have a choice to change the memory values. Suppose you want to perform the end operation with the different numbers. You go to that memory location, edit those numbers, and again do the same operation. Okay, but in our program, today's program, if you want to do any change, you have to rewrite the program. Agree or not?
Yeah, sir.
Yeah, but whereas in indirect addressing mode, you don't need to rewrite the program. You just need to edit the memory locations. Then you can do it. So when you in this case is only few numbers. There is no problem to edit or rewrite the numbers. But whereas when you go to large program, it is difficult to edit the entire program. Okay. So rather than that, you can just use the memory location to do that. That will be easy. So this indirect addressing will be easy when you do especially loops. When you do some 6 loops or 7 loops operation or 8 loops operation or maybe some iteration kind of things, then that time you you needed to store some a reference number in a memory location to do certain number of iterations or to do certain number of operations. So that we'll discuss in the next lab. So that will be indirect addressing using the memory location. Okay. So this is all for today's lab. So LMS is ready. I'll share the link today, and I'll also post all the video lecture links which are covered till now in both STAD as well as microprocessor also. So the software link I'll share, or if you can download and do it, it's fine. If someone face any problem, you can just put WhatsApp me. I'll share the drive link where you can download the software for the 8086. Okay.
Okay, sir.
Yeah. So if you have any clarification, you can ask. Else, you can leave the meeting.